Hello and welcome to Forrester High School Maths Department's National 5 Math Support Materials. My name is Mr. McDonald and I'll be talking you through your topics today. Today's learning intentions are to be able to assess whether or not a triangle is right angled. And you do this by using Pythagoras Theorem and its converse. So first of all, what I need to do is explain what the converse of a theorem is. Okay, Pythagoras' theorem states that if you have a right-angled triangle, then c squared, the longest side squared, is equal to a squared plus b squared, the two shorter sides of the triangle squared. It also works the other way around. If you have a relationship between sides of a triangle where c squared is equal to a squared plus b squared, then you have a right-angled triangle. No other type of triangle creates this relationship. So the converse of Pythagoras' theorem is if you have a relationship where c squared does not equal a squared plus b squared, then you do not have a right-angled triangle. That's what we're trying to prove with the converse of Pythagoras, that we do not have a right-angled triangle. So how does this work? What you'll be given is a triangle with all three measurements of the sides, and you'll be asked, is this a right-angled triangle? What you need to do first of all is you need to write the statement that is at the top right of this screen. If this is a right-angled triangle, then c squared equals a squared plus b squared. That's Pythagoras' theorem, that's what it states. And then what you have to do is you need to test that by completing each side of the equation separately. So the left-hand side of Pythagoras' theorem is c squared. In this case, c squared is going to be the same as 30 squared from my triangle. Remember, our longest side is always our c side. And then if we do 30 squared, we get 900. On the right-hand side is a squared plus b squared. That's the same as from this diagram, 18 squared plus on 24 squared. That's equal to 324 plus 576. If you add those two numbers together, you get 900. So as you can see here, my two answers, my c squared, which is 900, and my a squared plus b squared is also 900. So right here, we can make the conclusion as c squared, this might take a wee while, c squared is equal to a squared plus b squared Let's sort this out a little bit. As c squared equals a squared plus b squared, this triangle is right angled. Okay, you can't say it's right angled until you've done your little investigation into Pythagoras' theorem, but once you get both answers are 900, you can say as c squared equals a squared plus b squared, both things are the same, this is a right angled triangle. Okay, here we have a second example. Again, we've got all three measurements of our triangle. We're being asked, is this a right angled triangle? What we do, first step, is always to write down this statement. If this is a right angled triangle, then c squared equals a squared plus b squared. Second step is always to assess things separately, so you can't have any c squared equals a squared plus b squareds on the same line. We have to then break it apart. So our left-hand side is c squared on its own. And in this case, it's 26 squared. The right-hand side is a squared plus b squared. That's equal to 23 squared plus 10 squared. So using a calculator, 26 squared. 26 times 26 is 676. 23 squared plus 10 squared is equal to 529 plus on 100, which is 629 in the end. Now, just looking at our two answers from this section, 629 is not equal to 676. So what we need to do here is we say, as c squared is not equal to, let's get our not equal to sign in there, a squared plus b squared. Let's get all these squared signs looking proper. There we go. And one more. By the converse of Pythagoras, oops, this triangle is not right angled. Okay, so when your answers do match, you can say as c squared equals a squared plus b squared, this is a right angled triangle. If it doesn't match, you need to go a little bit further. You say as c squared does not equal a squared plus b squared, by the converse of Pythagoras, this triangle is not right angled. Converse just means the opposite of what Pythagoras means. Okay, so if you've got two things that are equal, you're using Pythagoras theorem normally. If you have got two things that are not equal, then you're using the converse of Pythagoras to prove that this is not a right angled triangle. Well done for getting to this stage of the video, Nat 5s. Remember, you can ask any questions on the day that your assignment is due. Make sure that you stay resilient and you try this as much as you can and upload all of your answers onto Teams so I can give you a mark for your work. Well done and keep up the good work.